All right, everybody. Hello. Welcome back to another video. We have another question over here. This question is from the IB Chemistry Paper 1 HL from the November 2020 batch. So it's the most recent set of questions that we have from the IB, excluding the May 2021 batch, of course, because their exams are still ongoing. So good luck to any May 2021 students watching. I hope you perform well in your chemistry exam, and hopefully this video brings you a bit closer to achieving the grade that you desire. Now, let's take a look at this question. What will be the major product in the reaction between but1ene and hydrogen bromide? All right, so this, by just looking at this question, you should know that this reaction is going to be an electrophilic addition reaction. Now, if you don't know what an electrophilic addition reaction is, I would highly recommend you to go and revise that, or you can actually just watch my previous video on this channel where I actually explain what electrophilic addition reactions are in briefly. So that is, you can also do that, but I would recommend you to go and highly revise it. This is only content for HL students. SL students don't need to know this. You don't need to know about major products and minor products. So let's kind of figure this question out. We have these four options. The first thing I like to do in such question is draw the structure of but. Let's draw the structure of but1ene. So it's but1ene, so there's a double bond on the first carbon. There's two hydrogens here. So this is the structure of but1ene, and this is the structure of hydrogen bromide. And now you know that the bond in hydrogen bromide is polar because of the difference in electronegativities between hydrogen and bromine. So hydrogen has a slight, you know what, actually, I'm going to draw this down over here and you'll see why I've done that in a moment. So because of the difference in electronegativities, this bond is polar, and that's why hydrogen, the bromine in hydrogen bromide has a slight negative charge and the hydrogen has a slight positive charge. Now, this hydrogen over here, it is attracted to this double bond over here because this double bond is a region of high electron density. And that means that there is a negative charge in this region of high electron density because electrons provide negative charges. So this hydrogen with a slight positive charge is attracted to this region. It calls it out. So this is going to attract this hydrogen. And this hydrogen is going to break away from bromine. And this bromine takes both the electrons in this bond. It takes the electron that it provided, and it also takes the electron that hydrogen provided. So this goes on, and this just becomes Br minus. And this H plus gets attracted to this bond over here. It goes and it quite literally attacks the bond, and this bond breaks. Now you may be asking, okay, we have H plus, which carbon will it attach to? Will it attach to this carbon or will it attach to this carbon? Because it could go either ways, right? Because you've broken the double bond between two carbons. So it can actually go and attach in any one place. So where will it attach? Now, the place where it will attach preferably would be the place where the carbocation that is formed. So meaning by what I mean by the carbocation is that when this double bond over here is broken, this hydrogen will go and attach itself to one of these carbons. It will either attach itself to this carbon or it will go and attach itself to this carbon. Now, either ways, there will be one carbon which will be left with a slight positive charge because it only has 3 bonds and it doesn't have an extra electron. So it will be left with a slight positive charge. Now, why is that? Is because when this double bond between the carbon is broken for this hydrogen, the electrons over here in this bond are used to form a bond with H plus. So one of these carbons is going to be electron deficient, which means that they will have a slight positive charge on them. So that's why they're called a carbocation. Now, which carbon becomes the carbocation depends on where the hydrogen attaches. If the hydrogen attaches on this carbon will become the carbocation. If the hydrogen attaches over here, this carbon will become the carbocation. Now, the place in which the hydrogen will attach is the place which will form the most stable carbocation. Now, out of these two options, which place will provide the most stable carbocation? That place will be if hydrogen attaches over here. That means this carbocation is more stable than this carbocation. Now, why is that? Now, I would like you to really make you think of why this is the case. I would like you to think of an analogy. Imagine all these carbons are like tent pegs. If you've put up a tent before, you know that if you peg the tent to the ground, so suppose I have a tent, right? This tent has it has four strings, right? Now each of these four strings hold the tent to the ground. Now just imagine I take off this peg and I take off this peg or these strings. The tent is going to collapse because it will be blown over by the wind. Just like that, in this case, if the hydrogen decides to attach itself to this carbon over here is only attached to one peg, which is carbon. It is only attached to one carbon. And that means it is very unstable. This carbocation is very unstable because it is only attached to one carbon. However, if the hydrogen decides to attach itself to this carbon, this carbocation is pegged to this carbon and this carbon, making it more stable. Now, this pegging in scientific terms is called the positive inductive effect. What that basically means is that the positive charge on this carbon is distributed among these two carbons, which increases the stability of the carbocation. Whereas if the hydrogen attaches itself over here, the carbon can only distribute its positive charge to one side, meaning it will be more unstable. And that is why the hydrogen will actually decide to attach over here because the carbocation is a lot stable over here. And this whole process that I just explained in very simple terms is called Markovnikov's law. You might have heard of this. So in Markovnikov's law basically states that hydrogen will choose to go to the carbon which is attached to more hydrogens. So when hydrogen is given a choice to attach between carbon number 1 or carbon number 2, carbon number 1, I'm going to keep it, so carbon number 1, carbon number 2. Carbon number 1 is attached to 2 hydrogens. Carbon number 2, however, is only attached to 1 hydrogen. So hydrogen decides to go with the gang, if that's how you would like to remember it, and it will go and it will decide to attach to the carbon with more hydrogen. So it goes and attaches to this carbon. Now, this carbocation over here has a slight positive charge. And let's not forget about our bromine. This bromine has a negative charge, and you know that negative and positive charges attract each other. So this bromine is going to go and attach itself to this carbon by donating a lone pair of electrons to the bond. So it forms a coordinate bond with the carbon over here. So that's why this is our final product. Now, what is the name of this product? The bromine is attached on the second carbon. So this product is going to be called 2-bromobutane. And that is answer number C. And this is also the correct answer. Thank you for watching. I hope that I have done a good job at explaining electrophilic addition and Markovnikov's law. If you have any more questions that you would like me to solve, or perhaps any question on this topic as well, please drop a comment below or reach out to me on my social media or send me an email and I'll be more than happy to help you out. So that's it for this video. Thank you so much for watching. I'll be back in another video with another question. Goodbye.